So um, before we talk about the semantics, we have to distinguish between some formulas that we can assign meanings to and some formulas that we cannot. And that's based on these definitions of bound and free variables. So first we define when we say an occurrence of a variable v in a formula is bound or free. The definition says if you can find that the occurrence belongs to some subformula that has the form of QVG, where Q is a quantifier for all who they exist, then this occurrence is bound. In other words, if V is in the scope of this quantifier that has the same V as a quantified variable, then the occurrence is found. Otherwise, the occurrence is free. So let's look at this example. So there are x and y in this formula. And so there are 1, 2, 3, 4, 5, 6. There are 6 occurrences of formula. 1, 2, 3, 4, 5, 6. So let's look at the first one, y. This y is, of course, obviously in the scope of its quantifier itself. So this y is bound. What about this x? Well, x is not bound because there is no quantifier that has this exists of x that contains this occurrence of x. So, okay, there's no subformula exists x that contains this occurrence of x. So this x is not bound, in other words, it's free. And this y is still in the scope of this quantifier, okay, with the same name, same variable name. So this y is a quantifier. I'm sorry, bound. Is a bound occurrence. Now the next one, of course, x is bound. This occurrence is bound, and this occurrence is bound, and this occurrence is bound. But careful that these occurrences are bound because of this quantifier, not because of the other quantifier. Okay. Okay, so I hope this is clear. But something that you have to be careful is the definition. There is we just defined an occurrence of a variable is bound. We can also say a variable in the formula is free or bound. And the definition is working this way. V is a free variable of f if V has a free occurrence in f. Okay? So, for instance, here, x is a free variable. This occurrence was free. So we can say actually x is a free variable of the whole formula. Although there are actually other occurrences of x, we don't care. If v has at least one free occurrence in the formula, then we can say x is a free variable. Okay. All right. Let me say this one first. A sentence is a special formula that has no free variables. In other words, there are no free occurrences of a variable. Okay, and the sentence is actually the valid formula that we are going to assign the meaning. So if a formula has free variables, then we don't know whether this is true or false because the value of the formula depends on may depend on the free variable. Okay. Some other comment here is bound variable is actually the name is not important. So we use this exists x, p, x, comma, x, but I could have renamed this x to z without changing any meaning because intuitively, if you say there is no x such that p of x, comma, x holds, well, you actually don't need to name those bound variables to be x. You can say there is no z that has no such that p, z, comma, z holds. They actually convey the same meaning. Okay, so bound variable can be always renamed. On the other hand, if you change x here to another bound variable z, then well, the meaning can be different, because when x could have been 5 and z could be 6, so then something can the meaning it could be different. Okay, so that's why we actually, when we define the semantics of first order logic formula, we're going to define semantics only to the sentences. Okay, so sometimes sentence is called a closed formula, and a formula that has a free variable is sometimes called an open formula. There's some terminology which is called universal clause of F, because it's somewhat convenient to write a formula without having all the quantifiers in front. But you basically mean that these free variables are actually not free, but they are universally quantified. So universal clause of F means that if F contains any free variable in it, they're actually universally quantified. So it's actually shorthand. You can say that the universal clause of F is prepending these universal quantifiers for free variables in front of F. Okay. Yes, okay, so this is what I just described. One terminology is called substitution. Substitution is an operation that substitutes term t for a variable v. Okay, so it's just a simple operation. Okay, so we usually say, okay, so what is